Hello everyone, my name is Kencho and I'm joined by my team member Tanuj. We are under the guidance of our respected supervisor Dr. Nancy Singla. Our project title is Image Re-Enhancement with Generative AI. In simple terms, our system enhances low-quality glaucoma fundus image and accurately classify them as glaucoma or non-glaucoma using a deep learning technique. Glaucoma is one of the leading causes of irreversible blindness, and early detection plays a critical role in its prevention. However, medical images are often noisy, low in resolutions, or unclear, which hinder diagnosis. Our objective is to improve the image quality using a deep learning-based enhancement technique like Autoencoder and ESRGAN, and then classify image using pre-trained CNN models such as Retinal 18. Here are certain objectives. Firstly, we conducted a thorough comprehensive survey of existing image re-enhancement. Then we try to improve the quality of images, and then we try to synthesize and rectangular image with an autoencoder. Here are the certain technologies and tool used for the deep learning and generative models. We have used our autoencoder, CNN, ESR, LPIPS, and SSIM for evaluating the image similarities. For image preprocessing, we have used CLAHE, OpenCV, and CLAHE. For programming language that we have used are Python, PyTorch, scikit-learn, NumPy, Math. And for the project development and environment, we have used Jupyter Notebook, VS Code, and virtual environments. Codes. In the preprocessing, we have done the normalizations and denoising, these images will fit into the autoencoder. And the autoencoder models. Firstly, we have built an autoencoder models. This is a model architecture, and then we will try to load and preprocess the images, and then define the heights and the image width. Then we will be training our autoencoder with 100 epoch, and while training, the validation loss is almost equal to 1.7 times 10 raised to negative 4. Then we will try to do the evaluations of our model, and then save the model. And then we will try to plot the training and this one training loss and the epoch. Then we will try to generate an images. That generated images will be stored in over here. Let me show you a certain generated image by this one. Generated. These are the certain images that were generated. And then we will be using ESRGAN and CLAHE for the. We will be using CLAHE, and this one is how we have used a CLAHE. And in the CLAHE, we have generated and applying. These are the images enhanced by the CLAHE. This one is image enhanced by the CLAHE. And then we have used ESRGAN is over here. And in the ESRGAN, these are the results that we generate after using an ESRGAN, which will try to enlarge the images. And then we will be using our classification models. We have used a classification model that is a Retinal 18. These are the epoch that we have been running. We have run on 10 epochs, and we shows that the loss is around 0.0043, and we have here a confusion matrix which shows predicted and this one, and finally it will predict whether it is a glaucoma or non-glaucoma. First thing is the two class is non-glaucoma, and our prediction is right, non-glaucoma. And the second thing is our class is glaucoma. From my project, what I've learned is that first thing is that effective of generative models. I've learned how autoencoders and ESRGAN can be used to generate and enhance medical images. Second thing is the importance of preprocessing. I've realized the critical role of image normalizations and denoising in improving model performance and image clarity. And I also understood how perpetual LPIPS and the structural SSIM metrics offer deeper insight into image quality and compared to the traditional metrics. In conclusion, this project demonstrates the potential of combining generative AI with deep learning to address the challenges in medical image analysis, especially for glaucoma detections. By generating synthetic data through autoencoders and enhancing images using ESRGAN and CLAHE, we improve image quality and ultimately boost classification accuracy.